Hello and welcome to day 3 of Advent of Code. I've already solved it again, just to get a good feel, to try to find the, interesting parts that I could highlight. Honestly, this one isn't as interesting as the previous two, in my opinion. It's very much a LeetCode thing. It's just implement an algorithm and yeah, just make sure it works. So again, like the previous times, try yourself. See if you can figure it out, see if you can write some nice code for it, and then watch me or other people solve it. So, again, the way I solved it was quick and dirty, and this session I want to improve on the code by using, again, a modeling perspective. So, if you don't know, we have these rows of numbers, and essentially we go from left to right and we need to pick a sequence of numbers like this with a fixed amount of numbers that when read from left to right is the biggest, right? So here, for example, what are the two numbers that read from left to right become the biggest number? Well, it's 9, 8, right? Because any other, like 7, 6 or 7 and 3, 7, 2, they're all lower than 9, 8. Here it's 8, 9. Again, we go from left to right. We pick only two. Here it's 7, 8. And here's probably 8, 9. No, sorry. Here's 9, 2. Right. So that was solution 1. Very, very easy. I want to look at part 2 again because it's a lot more interesting. So here it's the same issue, but now we have to pick exactly 12 numbers that when read from left to right make the biggest total number. So the trick here is lexicographical ordering, right? Not really going to explain much about it. Lexicographical ordering is basically saying that if you have two numbers and want to see whether one is bigger than the other, you really can do it from left to right. So you already know just by checking the first digit that this number is going to be bigger than the other one just by the first digit, right? You don't even need to check the rest. And if the first digit are the same, they just pick the next two digits and then you pick the bigger one, right? That's going to be the bigger number. So how is that going to help us here? Well, we're going to build up 12 picks, right? So we have a bank. This is called a bank in the story. We're going to build up 12 picks, and we're essentially going to say when a new it's a linear issue, right? If a new one comes in, can we place it somewhere in our row such that our final picks read from left to right is bigger than without the new proposed number? And the numbers here are called batteries, so that's why you see all this voltage and battery stuff. So the idea is that if we have a proposed, some picks, right, and we get like a new battery comes in, then we only have to check against A, B, C. We can just go from left to right, right? Like if F is bigger than A, then putting it here, and then no matter what batteries will come, this number, no matter what you build here, will be bigger than the picks we already had, right? Lexicographical ordering. If we know if F is bigger than A, and we know we have at least 4 batteries to come, then we can safely replace A with F and ditch the 4 batteries we already had. And I'm talking about ditching because we need to do it in order. So if we have, for example, here 8, 1 as our 2 picks, 9 comes in. Well, 9 is bigger than 8, but 9, 1 isn't a valid substring, right? So you cannot really take the place of 8. You can only take the place of the 1 because there's no batteries remaining. So I'm gonna model some things. So first of all, we have a battery. I'm just gonna say it's a U8. Why? Because they go from 1 to 9. And it seems like the smallest type. Then we kind of want to make an API, right, that represents the picks we made and can, for example, like add a battery to the end or like replace one of these batteries, like relink it, right? Since we do have to, say we have like 5 picks again, right, and we replace the second one with a new battery, we have to ditch the 3 to come after it. Now, the most natural thing for that will be a stack, which in Rust is a vector. However, I think it's easier if we just take a slice and then an internal counter, like, hey, how many picks are valid, right? So from a slice of 12, we just pre-allocate 12. And if we made 5 picks, then we just have 5 valid batteries at the beginning and a number that says, hey, we've picked 5 batteries. And then relinking at, say, battery 2, that just sets the number to 2. And then the rest will be like overwritten as new batteries come in. Right? So I'm going to call it picks. Since we're dealing with arrays, or at least I'm going to choose to deal with arrays, I will be using a constant parameter. So again, so batteries will be a battery, n of them, and we'll keep track of how many we've picked. Okay. That's import default. Right, so what's the picks that we're starting off with? I guess it's nicer to have an actual semantic name for it. So let's import picks. And we're going to say function start. Right, we're going to start picking. Batteries, that's going to be battery UI default is the thing, right? Yep. N of them. And we've picked 0 batteries. I think that's a good default. So my idea for this thing is to kind of use a fold over the every like step of the bank, right? So we have a bank, we keep giving a new battery, and then we're going to fold over picks and then just update it if we need to. So there's 2 options. Either the battery can replace one of the picks we already made, or it will be appended to the end, if possible, if there's space, right? So let's say let's do the first one. So relink will take a self, probably a mutable self, right? Then we will give an index, and we will give the battery itself. Not sure what that is. And we'll return the self. So in this case, we will say self dot batteries at the index will be this battery, and then we have picked, well, ix minus 1 battery plus 1, right? So if we say like, hey, replace the one you've already picked at index 0, then our batteries picked will stay at 1, and the 0th battery, the first battery, will become this new one. I think that's fine. We just have to make sure that this stays in bounds, which normally I'd make a result type and whatever, but for now we can just leave it. Let's create a try append, which is a new battery. Or I guess like append if space left or something like that, right? And then we can just say if self.batteries picked. If this is less than n, then we're going to add it. Self.batteries, self.batteries picked equals battery. Self.batteries picked plus equals 1 self. Okay, we probably need to restart the server. Okay, I think this is valid. It's not valid because it's not compiling. That's interesting. At least my types aren't showing. There are no types to show. Okay, this is fine. Now we got pics. We have this text, right? This is the actual input text. So we want to make a function that parses this to a bank struct, I'm assuming for myself. So we're going to create a bank. It's going to have batteries. Should be a vector of battery, right? That's the easiest way to do it. Let's create a freestanding function, parse bank. And again, we will have, I think it's nicer if we do, hopefully you can see it better now. Let's zoom in a little. I think it's nice if we just take the string, which we will assume is ASCII, and then we can always parse it to bank by just saying bank string dot as bytes, I think is bytes owned. Is this owned? I'm not sure. Okay, so we get the bytes, and then we can subtract like 0 from it, right? So what this is going to do is it's going to map the character 0 to the actual number 0. And because in ASCII, like the characters 0, 1, 2, 3 are all sequential, this is going to map the characters exactly to their numbers, right? Byte 0, byte 1. So that's pretty nice. I think this works. So we can already start working on it. We can already start parsing. Let input text. Read to string. This is inputs.txt. We're going to expect that the file exists. And then we're going to say let sum equals, it's as simple as include input bytes, or sorry, input text dot lines dot map. And for every line, we're going to call this. And for now, let's do something stupid like bank.batteries 0 or something. Right, and then just sum. Okay. So this is going to print the sum of all the batteries, of all the first batteries, I guess. Right? 2, 4, 1, blah, blah, blah. Whatever. You can already see that I solved it in the command line there. Okay, I think this is nice. We want some way to kind of iterate over every battery in the bank. So that's input. Let's call it step through. I'm gonna step through itself. Do we need by reference? Let's do this. Doesn't matter. And we are going to return an iterator of not battery because there is one extra information that we need to actually properly make a pick, which is we need to know how many batteries are remaining. If we, for example, like the example I gave here was if we've picked 8 and 1 and we encounter a 9, even though 9 would be lexicographically in the first place better than 8-1, you cannot do this because there are no batteries left, right? So I'm going to attach that information to this iterator. So I'm going to say, start with bank step, proposed, or we could say like proposed battery, right? So battery, and then batteries remaining, which is a usize. Okay. So we're just going to step through and then propose every battery to say like, hey, you've got these picks. This is a battery. Update your picks and see if you can actually use the battery or not. So all this is going to do is we're going to iterate through our batteries. We can do into iter. And then we can map. Well, let's enumerate, right? Then we can map index battery, and then we can say proposed battery, which is just the battery. How many are remaining? Well, the length of amount of batteries minus the index minus 1. Okay. Closure may outlive the current function. It borrows self of batteries, which is owned by the current function. Let's see if we can figure out what's meant here. So this is borrowed. Sorry, this is consumed here. It's moved here, but here it is borrowed, right? So let's do iter, and let's just deref this. Right, because this is an iterator. Can we do this? Yes, we can. Okay, that makes it easy. So the idea is that we're going to step through, get every one of these proposed batteries, and fold it over the picks, right? So all we really need for now is a function that says like find best relinking spot or something like that, right? You'll get some picks. So this should also get this generic parameter. And then we get the proposed battery. Let's move this below here. Proposed battery, and then we're going to return our updated picks. Right? And the idea is that we will so we will map the bank to we'll get the linkage, right? Find strongest linkage of this size, of size constant, and we're going to give it the bank. Is that all we need? I think that's all we need. And we can say like, oh, well, option let's create a model for like our final like 12 picks, because this is a intermediate, right? So let's say we have picks. This is our like max amount of picks. And we can create a, I guess, coupling, right? And this is always going to be of this size. And it's just going to hold, again, an array. Okay. Then we can return this. I'm thinking because internally, maybe do a try into or something. Yeah, it's we'll see, right? Anyway, we will create either we will create this coupling or we won't. And we can create it, we can call it coupling. Okay, great. So bank step through dot map fold. Actually, we will begin our picks, and then we will find our best relinking spot. And then once we have our picks, then we should convert it to an optional coupling n. Right? Or yeah, I'm thinking a result type. So let's do it with a try from. Try from picks, and obviously add this to the impl for coupling, and Let's move this actually to coupling. Okay, let's see what this will be. So I think it's pretty easy, right? Like if picks dot batteries picked equals n, then we say okay, coupling picks dot batteries, right? Else error, and then your error type, which I will just ignore for now. Normally you'd make an error struct, but this is just an algorithm. And then we will just do a try and do, and then okay it. Okay, so now we just need to work on what makes proposed battery change our picks. And I guess we should iterate through it. Right, we can iterate through the batteries. We're going to enumerate them because we're going to know the index. And we're going to find, I guess, find map, because we want to skip the actual battery. Find best free linking spot. Let's improve picks. Let's call this improve picks. Sorry. Here we want to find the best free linking spot and actually like go through with it. So let's create a new function. Find best free linking spot. And this will turn an optional usize for if we have a good relinking spot or we don't. So here we can actually do this. And here we can do the find map. So this is a existing index, I guess, and an existing battery pick. And we're going to say that if our proposed battery in value is bigger than the existing battery, and this is where the crux lies, right? And if there's enough batteries remaining, such that we can actually fill the pick, so that would be, so this is how many batteries we would have at this point if we relinked at this index, right? Index 0, we would have 1 battery. This is how many batteries would be remaining, and we need to make sure that that is at least n. Otherwise, we don't have enough batteries. And now we can return the index. Or nothing. Right? And then all this is going to do is it's going to match on this. So match, again, picks, and this should go by reference, honestly. And the same goes for that. So, okay. If there is a relinking index, then we're simply going to, this should be mutable. Picks dot relink at the relinking index with this proposed battery. Yeah. And if there's nothing, then we can just try it at the end. And the space left. Okay, proposed battery. Okay. And then regardless of what we do, we return picks, match arms of ink. Yep, because I forgot to close. I guess they both kind of return self, right? Then we can just skip it entirely. Like so. Yeah. And then we want it to be mutable. Nice. Okay. That worked. And I think that should be it. So Let's go through the input text. That is not right. Let's update this first. So we have a bank. What do we want to do with a bank? Well, we want to find the strongest coupling. We want to do it of size 12. That's going to create an optional. So we want to unwrap. And then we want to get the value of the coupling, right? So we didn't have an input block yet. Let's create an input block. Okay. We want to create the value. Let's do U64 because it will actually be able to contain it. Now we want to solve the batteries. Okay. We want to reverse it because the last battery will have a power of 10, 0, then plus 10 to the power 1, plus 10 to the power 2, etc. Right? Yeah, I think this is fine. And then we want to map b times 10 to power to be 10u64 I dot sum. Okay, we can't do that. Let's just do it as u32. We'll be fine. We'll be fine. We won't be fine. Let's see what I'm doing wrong. Yes, this should be 64. Can we get away with that? Probably not. So this should be fine. So we've unwrapped, and now we will determine the value of the coupling to then run 1737, 1736. Ooh, we're doing something wrong. Let's try to figure out what we're doing wrong. I think I already see what it was, the issue, which is that since we're working in just one file, kind of everything's public, and I kind of mindlessly iterated over the batteries of the picks. But obviously, you cannot do that, right? So let's actually create an iter function. It actually takes into account the amount that we have picked. Item equals battery. Should probably be a reference, but I don't think it matters that much. Self the batteries. Dot self dot batteries picked. U8 is not an iterator. Is this? Is this? That is. Okay. And now we can just do this. And this should work. 173685. 173685. So that's day 3 solved, and I'll see you for day 4. Bye bye.